In this video, we're going to take a look at the 10 things that it takes to fully investigate a function. Let's say that you're given a function x squared plus 5x plus 4, and then you simply type in that equation in your calculator. And then once it's entered in, you push second table, and here are the table of values. So you can build a table with technology. That then is done. Next, you need to be able to make the graph. Well, go ahead and push graph, and if you haven't pushed Zoom 6 or Zoom Standard, you should do that. And the graph shows up, and as you can see, it's an x squared equation, so we have a right side up parabola, and it looks like this. Graph, you can sketch that. You are going to want to be able to find the x-intercepts, and we're going to talk about that here in a minute. Next would be the domain. The domain is all of the inputs, all of the x values that you can put into the equation and have something come out of it. Well, there's nothing here to restrict the domain, so you can put any number you want into this equation and something's going to come out. Typically when you look at the graph, you think of the x-axis, which is right here. The x-axis running horizontal. What's the smallest number that you see on the graph? What's the largest? And this graph continues forever because it's a parabola. So realistically, this would go from negative infinity is less than x, which is less than infinity. Or you could just simply write that as x equals all reals. There's every number that you can think of that's going to be in that domain. Next, the range would be your vertical axis or your y-axis. What numbers are you going to get out of this parabola? The output. Well, you take a look at the graph, that is your picture of your outputs. It bottoms out down here and it goes all the way up. So we know this is going to go to positive infinity. Now we just need to figure out where. So we need to find or locate this point down here. That's going to help us find the range. We're going to need that minimum point. So I'm going to jump over here and talk about how you calculate the minimum point of a parabola that opens up, because it has a minimum down here. If it's a parabola that opens down, somewhat looking like this, then you would have to find a maximum point, which your calculator can also do that. So let's take a look at this minimum point. We go second calc. When we push second calc, what do we want to calculate? A minimum. So we choose number 3. Now we need to create a boundary. We need a left bound and a right bound. So enter on this side of your lowest point, enter on this side of your lowest point, and then let it run it, and you can see that it's negative 2.5 and negative 2.25. So the minimum point is negative 2.5 for the x value, negative 2.25 for the y. So there's my minimum point. So then my range tells me that this bottom point down here is negative 2.25 on the y-axis. So negative 2.25 is less than or equal to y, which is less than infinity. Or you can just simply write that as y is greater than or equal to negative 2.25. The next thing we want to calculate is the x-intercepts. Where is this hitting the x-axis? You could push the trace button and you could try to find it via trace. It doesn't really hit it so well, so that's not necessarily the best way. Another way to do it is just to take this, you could plug this into the quadratic formula and have that come out, or you could factor it. Factoring it leaves x plus 1 times x plus 4, and then you can find the x-intercepts using zero product property, set that equal to 0, split it up, and x plus 1 equals 0, and x plus 4 equals 0. Well, then x would have to have been negative 1, and x would be negative 4, and those would be the two x-intercepts. So you have to know how to do that. Factor or quadratic formula, set it equal to 0, and it's an x squared equation, so there's 2. Y-intercept, if you plug in 0 for y, or excuse me, if you plug in 0 for x to find the y-intercept, you take it, you plug in 0 here, plug in 0 here, these are all going to zero out in your x spots, so the y-intercept would be 0 for x, leaves 4 for y. Same thing down here with your x-intercepts, make sure that you get them as an ordered pair, because it is a point, or are points on the graph. Finally, leaving the maximum point. When you look at a parabola, there's no point that you can make up here as a maximum. There's no ordered pair for these points up here, so it has no maximum point, none. Line of symmetry. Parabola has a line of symmetry right down the middle. It has a vertical line. It hits the x-axis right there. So then you would say x equals negative 2.5 would be the equation. Yes, it has symmetry. Does it have an asymptote? No, there's no line that this graph approaches but doesn't get to. So therefore there is none or no. And those are the 10 things that it takes to fully investigate a function. In the next video we'll take a little bit more complicated function. This is for a parabola.